So this video is so you could double check and understand how to do every single question on this practice test. And right here it's open response. On tomorrow's test, guess what? It's going to be multiple choice. Yay. Yay. Okay, so the print is kind of bad. I apologize. But anyways, we do have parentheses with an exponent on the outside, and that is either rule 3 or 4, whichever one you want to call it, where you have to distribute the outside exponent in. So I need to take that 4 and put it right there and also put it right there. So when I distribute that 4, I will have 3 to the 4th and also x to the 4th. And I believe, if it were open response, I would leave it like that. But I think the multiple choice actually works it out. So you're going to have to get on the calculator and go 3 times 3, 9 times 3, 27 times 3. I believe that's 81. So 81 x to the 4th. So that is the answer. Let's move on to number 2. Number 2 is crazy. So what I would do when you have parentheses with an exponent on the outside, Melissa, you're supposed to distribute that outside exponent to each inside exponent and multiply, because of power to a power you multiply. But before doing that, see, there's a lot of terms in here. What I would do is zoom in to the inside of the parentheses, ignore the outside right now, and see if there's anything that you could do. Again, I apologize for the print. It's kind of ugly. But when I look at the 3, the coefficient 3 and the coefficient 2, there's nothing to do there because 3 over 2, you can't reduce it, right? But then when I look at the x's, I do have 5 x's up on top. All 5 x's are going to cancel out with 5 of these 6, which means I'll have 1 left over. Does that make sense? So all 5 x's up on top disappear. You could scratch them out. They're gone. On the bottom, we have 1x left over. Now let's cancel out the y's. On the bottom, you have y squared. That's a total of 2 y's. That cancels out. On the top, we have 3 of them. So 2 on the bottom cancel out with 2 of these 3, which means I have 1 left up on top. Is this making sense? This is that rule of canceling. Okay? Now, the z's, even though I have a z up here and a z down here, I cannot cancel. Because right now I have z to the negative 2, and z to the negative 2, that rule says whenever you have a negative exponent, you have to move it to the other side, and it'll become positive. So I need to take this z to the negative 2. I like to circle it and draw an arrow. And when I move it up, it will become z to the positive 2. Check this out. I'm actually going to write it times z to the positive 2. And what I really have now up here is z to the 1 times z to the 2. So that is z to the 3rd. So this right here will be z to the 3rd. Now notice it's getting really ugly. It's getting really ugly. So in order to not make mistakes, I'm going to rewrite what I have so far down here. I'm going to put the parentheses. I'm going to put that negative 2 on the outside. I'm going to put the fraction on the inside. And let me write what I have so far. Up on top, I have a 3. Let me write that down. That one didn't change. It's still a 3. I do not have any more x's. No more x's, but I do have a y to the 1. So let me write that down there, y to the 1. And I do have the z to the 1 times z to the 2. That's z to the 3. So I'm going to put z to the 3rd power. Now in the denominator portion of this fraction, we have a 2 left over. So I'm going to put a 2 down there. And we do have 1x, x to the 1. And we don't have any more y's down there, and we don't have any more z's down there. Are you with me so far? Okay. Now the power of 1 and the power of 1 are unnecessary, but I'll leave them there anyway. So now at this point, we need to make a decision. Do we want to distribute the outside exponent to each and every term on the inside, which means that they're all going to have negative exponents, which means we're going to have to flip all of them, right? Or we could do that trick that we learned yesterday, change that negative power of 2 to a positive 2, but make sure you flip this fraction before doing anything. So we could do that little trick, or we could distribute the negative and then flip all the terms that are negative, which are all of them. So what do you guys want to do first? Flip first and then distribute, or distribute first then flip? Flip first. Okay, we could do both if you want. But look, the flipping first really changes this negative to a positive as long as I move the numerator down to the bottom and the denominator up to the top. So I need to take this whole thing, move it down, this whole thing, move it up. So that's what I'm going to do right now. I'm going to change the fraction on the inside of the parentheses, and that -2 on the outside is going to become +2 because I am going to flip it, and I'll have a 2x up on top and a 3yz to the third on the bottom. Now I could have distributed to each and every term. I'd get all negative exponents, then I'd have to flip anyway. So there's like a little trick that makes it a little bit, I think, easier to do, right? And now that I flipped it, now that I don't have a negative anymore, now I'm going to distribute that 2 to each and every term. So let me zoom in here. And if I take that 2 and put it on the 2, I will have a 2 squared. If I take the 2 and put it on the x, I will have an x squared. If I take the 2 and put it on the 3, that'll be a 3 squared. And if I take the 2 and put it on the y, that'll be a y squared. If I take the 2 and put it on the z to the third, that'll be a z to the what? 6th, because you multiply the power to a power. So now the only other thing to do, guys, you can't cancel out anything because there is no x on the bottom, there's no y's or z's up on top, nothing to cancel. But we could do the 2 to the second. What's 2 to the second? 4. And how about 3 to the second? 9. And let's just rewrite everything. 4x squared over 9, y to the second, z to the 6th. That's all you could do. That is your final answer. Nothing else to do. So let's move on. That was a pretty crazy problem for number 2. Let's move on to number 3. So on number 3, once again, I recommend to look at the inside and see if you could cancel anything out. Is there, like the m, could I cancel down here? No. G's? No. N's? No. Nothing, no variable could cancel. However, when you do have coefficients, again, what I like to do is look at it as if it were a regular fraction without the variables, 2/4. So when I think of 2/4, 1/2, right? 2/4 could be reduced to 1/2. So what I like to do is actually just scratch out the 2, scratch out the 4, put a 1 up there and a 2 down here. So there's my 1/2. Yay? Okay. So there's nothing else to do. Nothing else to do. So I'm going to rewrite it. There it is, rewritten. And then now, since there's nothing else to do on the inside, I'm going to distribute the outside exponent 3 to each and every term on the inside. So if I were to put the 3 on the 1, it'll be a 1 to the third. I'll write it just to show my work, even though it's not going to be there. And then 3 onto the m squared, what do I get? M to the what? 6 power, that's right. And then the 3 onto the g to the third, what do I get? G to the 9th, there you go. And on the bottom, the 3 on the 2, that'll be a 2 to the third, which later on will change to 8. And then the 3 on the end of the 7th, that'll be an n to the what? 21, perfect, all right. So the only other thing to do to this answer is to take the 1 to the third, which just becomes 1, which you don't even need, you could just scratch it out. And then the bottom one, 2 to the third, what's 2 to the third? 8. So your final answer is m to the 6th, g to the 9th, over 8n to the 21. That's it, there's nothing else you could do. Let's move on, number 4. Number 4, it's kind of fun. You could actually reduce, if you look at the numbers, you could actually apply the power of 0 rule that changes to 1. You could apply the negative exponent rule that moves down to the other side, becomes positive. So you have a bunch of different rules to choose from, but you have to apply all of them, okay? So which one do you want to do first? And there is no, you're saying which one do I have to do first? There is none. As long as, like, anyone. So like, you want to do the x to the 0, you could do that one first. Or you want to move that y to the -2 down to the bottom, you could do that first. So you could be doing a problem completely different than your partner and you'll get to the same answer, right? So which one do you want to do first? How about this, the coefficients? Let's just look at that fraction. Let's look at -20 over 4. What does that mean, -20 over 4? That means -5. It really means -20 divided by 4. So the answer is -5. Where does the -5 belong? On top. So I'm going to just scratch it out and put a -5 up on top. And what else could we do? Another rule is I have x to the 0 right here. That's just what? That's just 1, right? So I could just scratch it out as well. I mean, I could write a 1 right here and then go, okay, -5 times 1, it's still going to be -5. So that's pointless. Let's just scratch it out. Anything to the 0 power is 1, scratch it out. And we also have the rule that says negative exponents have to be moved to the other side of the fraction and they become positive. So check this out. I want to put y to the positive 2 down here. So I moved it. Now let me just scratch it out so I don't get confused anymore. The y to the -2 that was on top is now on the bottom. Now this is getting really messy, so let me rewrite what I have so far. Up on top, I have the -5. And what else? That's it. Nothing else up on top. On the bottom, what do I have? I have y to the 5th times y to the 2nd. Let's use rule 1, and let's actually get an answer. What's y to the 5th times y to the 2nd? Y to the 7th. And we're done.
Wait, what happened to that one?
So this is the answer, but let me tell you, on the multiple choice portion, they're going to write it like this. They're going to put 5 over y to the 7th, and the negative sign that's right here, they're going to put it out here in the middle. So they're going to write it as negative fraction 5 over y to the 7th, just to let you know. Moving on, number 5. So number 5, once again, I like to look at the numbers, the coefficients first. The -2 divided by 8. Now, -2 divided by 8, you can't really do it, but you could rewrite it. You could reduce it. That's what I meant to say. You could reduce it. So what does -2 over 8 reduce down to? -1 over 4. There you go. -2/8 reduces down to -1/4. Now, how about the x's? Well, I have 3 x's up on top, 7 x's on the bottom. 3 of them cancel with 3 of them. You will have 4 left over on the bottom. So you will have x to the 4th on the bottom. And that's it. There's your answer. However, on the multiple choice test, for some reason, they always put the negative in front of the fraction, not on the numerator or the denominator. So they're going to write it with the negative sign in front of the fraction, not up here. Let's move on to number 6. 6 is fun. There's a lot of rules right here. Let's start with which rule? Distribute. All right. Okay, so let's take that power of -3 and let's distribute it to the inside of the parentheses. So we're going to put it on the 2. I will have 2 to the -3 power. Let's put it on the a to the -2, which becomes what? A to the positive 6. Because a -3 times -2 is a positive 6. And then take that -3 and put it on the b. That'll be b to the -3. And on the bottom, we're not even going to mess with that. I'm just going to rewrite it right now. 5a squared b to the 4th. Are you with me? Okay. And now we could apply other rules. Is there anything to cancel? Is there anything to cancel? The a's. How many a's could cancel? 2. So I'm going to cancel 2. All these a's, both of those a's are going to cancel out with 2 of these 6, which means how many do I have left up on top? 4. Okay. And the b's can't cancel yet, but I do need to move all negative exponents to the other side and make them positive. So that's including this 2 to the -3. I need to get that, move it down, and it'll become 2 to the +3 and put a multiplication between it. And this b to the -3 is going to move down, and it's going to become b to the +3 down here, and you put a multiplication sign between it. Now, since we already moved it, you probably want to scratch them out so you don't get confused. You already moved them down. They already became positive. And now, as you can see, it's getting really ugly. So I would like to rewrite what I have so far. So down here, I have what left up on top? A to the 4th. Okay, so let me put a to the 4th up on top. A to the 4th. And on the bottom, what do I have left? I have, what is this really? That's 8 times 5, because there's a 5 here. And then b to the 4th, b to the 3rd, that is b to the 7th. You add exponents, that was rule 1. So my final answer will be a to the 4th over 40 b to the 7th. So number 7, are there any negative exponents? No. See, so, some people say, oh, there's a -3 right here. I need to move it to the other side. No, that's wrong. This is just a nice negative number, right? It doesn't have a negative exponent. It actually has a positive 1 as an exponent. So there are no negative exponents. You're not going to be moving anything from one side to the other. If I take a look at the coefficient 7 over 3, could I reduce that? No. So I need to leave the 7 on top, leave the 3 on the bottom. But when I look at the variables, there is 3 c's up on top, and there's 3 c's on the bottom. So I could cancel all 3 of these with all 3 of these. So there are no more c's. ¿Entienden? Sí. Okay. And now there's d's. There's d's on the bottom and on the top. There's 1d on the bottom. This 1d is going to completely cancel with one of these 5, which means I'll have 4 left over up on the top. So let's rewrite our answer. We have what left over up on the top? 7, d to the 4th, and negative 3, and that's it. Now again, your multiple choice answer is going to have the negative sign out here in front of the fraction. So 7d to the 4th over 3, and the negative sign in front of the fraction. They're not going to leave that negative sign on the 3 in the denominator. Number 8. If you look at the inside of the parentheses, there's a lot of things you could do, but that would be a total waste of time. Because that rule that says anything to the 0 power is 1. Now this is in parentheses, so that means that this whole thing equals 1. So the answer is 1. Sas.
Is it going to be the test?
Yes, every single one that you see right here is going to be either identical to what you see on the test or very similar. Number 9 is kind of fun. It has rule 3 where you have to distribute, and it also has rule whatever that number is where you cancel. Okay, so let's start by distributing
7.
Yeah. 4.
the 4. Let's put that power 4 right there on the 2, and you'll get 2 to the 4th. Distribute that 4 right onto the x, you'll get x to the 4th. Are you with me?
Yeah.
And on the top, we're just going to rewrite it x to the 6th. So after distributing, there is another rule you could do, which is canceling. So I have 4 x's on the bottom. I have 6 x's on the top. 4 x's cancel with 4 of these, and you'll have 2 left over. So your answer is x to the 2nd over 2 to the 4th.
32.
I would go 2 times 2, 4 times 2, 8 times 2, 16. Yeah, so 16 on the bottom.
Oh my God.
Number 10 is interesting. Now, whenever you see parentheses, ladies and gentlemen, whenever you see these guys, check and see if there's an exponent on the outside that you have to distribute in. And there is nothing here, there is nothing here. So if there is no exponent on the outside, like let's say I had a 5 right here. Well, then that would be negative 30 when I multiply it, right? But there's nothing out there. There is no exponent on the outside. So in reality, guys, the parentheses are totally pointless. So what I would do is just rewrite it without the parentheses. So that's what I would start with. A times b to the negative 5 times c to the negative 6. We don't need the parentheses. So we could apply rule, whatever that is, the negative exponent rule. Again, the number doesn't matter as long as you remember what the rule is. Negative exponents need to be moved to the other side of the fraction. There is no fraction. Okay, make it look like a fraction. Put a fraction bar. And this b to the negative 5, you're going to move it down. It's going to become b to the positive 5. This c to the negative 6, you're going to move it down. It's going to become c to the positive 6. So you could scratch them out up on top since you already moved them and changed the sign. So your answer is a up on top over b to the 5th, c to the 6th. You're done. I'm done. Moving on, number 11. Right here on number 11, what rule do we have to apply?
Oh,
The negative exponent rule. Yeah.
yeah.
So you need to grab this term and move it to the other side of the parenthesis to make it positive. I mean, not the other side of the parenthesis, the other side of the fraction. So let's make a fraction bar, and let's draw this to the other side. Now, if you did move it down there, there's going to be nothing left up on top, and you'll get 2 to the positive 2 on the bottom now. So your final answer is 1/4. Yeah, after he said it. Yeah. Number 12. Dang. I see negative exponents. I know I have to move them. But even before that, is there anything I could cancel? And I like to start with coefficients. I like to look at the number. Yeah, Negative 12 over 2. That's really negative 12 divided by 2. The answer is negative 6. Where does the negative 6 belong? On top or bottom? Top. So I already know that this becomes negative 6 up on top. So negative 6 is going to be up on top. Now, I know I need to take this t to the negative 1 and move it down, and take this t to the negative 3 and move it up, and they're going to become positive. But before doing that, let me cancel out what I could cancel out. Like the u on the bottom cancels out with one of these 5 u's, which means I have 4 u's left up on top. And then also I'm going to move this x to the negative 4 down here right next to the x to the positive 5, and it'll become x to the positive 4. So I might as well scratch that out since I already moved it down. Notice I didn't scratch these guys out because I haven't actually moved them yet. So let me rewrite everything. Here's my fraction bar. Up on top, you guys told me we have a negative 6. And let's go with the t's first, right? How many t's do I have up on top after moving it up? I have t to the 3 up on top, right? Actually, I'll make that a capital T. And on the bottom, how many t's do I have? 1 t on the bottom. Okay. And then how many u's do I have up on top? U to the 4. Sorry, I made my t look weird. And then what else is left up on top? On top. Nothing. But on the bottom, we really do have the x to the 5th times x to the 4th. And what is that? X to the 9th. Now, the only other thing we could do is cross out t's. So there's 1 t on the bottom that disappears with one of these 3, which means I have 2 left over. Final answer is they're going to take that negative on the 6 and put it in front of the fraction. They're going to put 6 t squared u to the 4th over x to the 9th. Number 13. You have to think of all the rules that you know and see which rules you could apply. Like, is there any negative exponents? No, we don't have to move anything from one side of the fraction to the other. Is there any parentheses with the exponent on the outside? No, we don't have to distribute anything. So you go through all these different rules in your head, and you realize the only thing you could actually do right here is cancel what is alike on the numerator and the denominator. So you do have m to the 8th and m to the 7th. All these 7 m's cancel out with 7 of these, and how many will be left? 1. So I'm going to put a 1 up here. And when I look at the n's, well, there's an n up here, but there's no n's down here. So I move on to p's. I do have 2 p's up here that cancel out with both p's down here. So my final answer is m to the 1, n, but I'm not going to write m to the 1. I'm just going to write mn. And yeah, you could put over 1, but that's a waste of time because anything divided by 1 is the same value, right? If I say 5 divided by 1, you're not going to leave it 5 over 1. You're going to say 5. So right here, mn divided by 1, that's just mn. And that's how they're going to write it on the multiple choice test tomorrow. Number 14. You know this one? What's the answer? 9 over 4. Good job. Now, there's 2 ways of doing this. Rule 3 and 4 is where you have parentheses and you have an exponent on the outside. You could distribute that outside exponent to each term on the inside. But we notice that this is a negative 2. So if I put the negative 2 right here and the negative 2 right there, I'm going to have to move them because negative exponents have to change to the positive, right? So you could distribute and then flip everything, or you could flip everything and make this a positive 2 and then flip the inside fraction. That's the route I'm going to go. I'm going to take this negative 2 and make it positive, and I'm going to take the 2 and move it down here and take the 3 and move it up there. That's the trick. Flip your fraction and it'll change that outside exponent to become positive. So what do we have on the inside of the parentheses? We really have 3 over 2. And that negative 2 on the outside actually becomes positive 2 because we flipped the fraction. Now, if you don't like that, if you don't like doing that trick, you could easily take the negative 2, put it there, it'll be 2 to the negative 2. You could take the negative 2, put it on the 3, it'll be 3 to the negative 2. But then you have to move this one down because it has a negative exponent, and this one up because it has a negative exponent. So you'd end up with 3 squared over 2 squared. So you could get the answer this way as well. The answer is 9 over 4. But you see what I did, I took the fraction, I flipped it first, and then I'm going to distribute. and I'll get the 3 squared over 2 squared, which is really 9 over 4. Same answer, just done a little differently. So I explained both methods. I prefer to flip the fraction first and then distribute. Or you could distribute, then flip. Number 15. Again, there's many rules we could apply. I like to, whenever I see a fraction like this that has coefficients on the numerator and the denominator, I like to look at it as if it were a single fraction with just numbers. So if I took a look at 44 over 4, what's 44 over 4? 11, because 44 divided by 4 is 11. Now where does the 11 go? Up on top or on the bottom? On the top. The 44 is on top, so when you divide, you end up with the 11 up on top. Now if it would have been 4 on top, 44 on the bottom, then the 11 would have been on the bottom. Does that make sense? Okay, so we reduced. We did 44 divided by 4, we got 11. Let's move on to the r's. Notice that there's 4 r's on the bottom, 5 r's on the top. So let's cancel out all 4 of these r's on the bottom. Let's cancel them out with 4 of these 5. So that means that there's only 1 left up on top. And then I'm going to take this s to the negative 7. Because it's a negative exponent, I'm going to move it up, and it's going to become positive. Check this out. I'm going to put times s to the positive 7. Are you with me? Now, since I already moved it up, I'm going to scratch it out down here. Okay? So since it's getting ugly, let me start rewriting my answer. What's left on the bottom, guys? Nothing. So I could put a 1, but at the end of it all, I'm going to erase it. Right? Up on top, I have an 11. And then I have a what? R to the 1. I'm just going to write R. And last but not least, what is s to the 3rd times s to the 7th? S to the 10th. Add the exponent. So s to the 10th. So like I said, anything divided by 1 is the same value. So I'm not going to write it over 1. On your multiple choice, you're not going to see it over 1. You're just going to see 11rs to the 10th power. 11rs to the 10th power. Number 16. There's parentheses with an exponent on the outside. What are we supposed to do with that outside exponent? Distribute. Of course, always try to look on the inside and see, could I reduce 6 over 7? No. Right? If it were 6 over 8, you could reduce by 2. But 6 over 7, you can't. Check and see if you could cancel out w's with anything. No. P's with anything. No. Nothing. You can't do anything on the inside. So it is good to then distribute the outside too. So what I'm going to do is I'm going to distribute the 2 to each one at a time, and then I'm going to show what I get. So if I put the 2 on the 6, it'll be 6 squared. If I put the 2 on the w to the 5th, power to a power you multiply, you're going to get w to the 10th, right? On the bottom, when I take the 2 and put it on the 7, it's going to be 7 squared. When I take the 2 and put it on the p to the 6th, I need to multiply exponents, p to the 12th. When I take the 2 and put it on the r to the 3rd, it'll be r to the 6 because you have to multiply. And now the only other thing to do, Andrea, is to do the 6 squared and the 7 squared. There's nothing to cancel. All you have to do is 6 squared is what? 36. And 7 squared is what? 49. So our final answer is 36 w to the 10th over 49 p to the 12th r to the 6th. And that's it. Nothing else to do. Can't reduce it, can't cancel, we're done. 17, we have parentheses with an exponent on the outside. Now, these are fun because of this negative sign. This whole thing is a number that's negative, right? Now, because we have a number that's negative to an even power, is the answer going to be positive or negative? Positive, that's right. So I already know my answer is going to be positive. I don't even have to worry about this guy anymore. But I do need to do what with the outside exponent for? Distribute. So I want to put the 4 on the 2, so it's going to be 2 to the 4th. I want to put the 4 on the x, it's going to be x to the 4th. I want to put the 2 on the y to the 5th, which is going to be y to the what? 20. And I want to put the 4 on the z to the 9th, which is going to be z to the 36. That's right, power to a power, you multiply. So we know it's positive. The only other thing we could do is 2 to the 4th. 16. So you have 16, x to the 4th, y to the 20th, z to the 36. Moving on to the back side. Again, parentheses with an exponent on the outside. We need to distribute that 4 to the 3, to the g to the third. Okay, so I get 3 to the fourth. I get g to the 12th. I get h to the 16. That's right. Now, the only other thing I could do is 3 to the fourth. 81. Because, and if you don't know it, calculator, right? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And we still have the g to the 12th, the h to the 16th. Sarah, you agree with that? Let's move on to number 19. Again, we have parentheses with an exponent on the outside. So if you guys say distribute first, if you did distribute the negative 2 right here, it's going to be 2 to the negative 2. It's going to be a to the negative 2. It's going to be a to the negative 4. And all these negatives you're going to have to flip anyway, right? So it'd probably be a good idea to flip first, change that to positive, and then distribute. And you know what? I always say this. Whenever you have parentheses with something on the inside, try to do something on the inside to make it nicer. Is there anything else you could do? You could cancel out the a's, right? So even before distributing or even before flipping, you could take this a right here and scratch it out with one of these and you have one a left. So let me rewrite this problem. And we end up with 2 over a inside of the parentheses to the negative 2. And now let's do the trick that we said. Let's take this negative 2 and make it a positive 2 as long as we flip the inside fraction and make it an a over 2. Agreed? And now finally, my last step would be to actually do a over 2 to the second power. So I'm going to distribute this 2 on the outside and put it on the a. It's going to be a squared. And put it on the 2 squared. So my final answer will be a squared over 4. Ta-da! EC. Number 20. Fun stuff. You have parentheses with an exponent on the outside. You have to do what? Distribute. Now, some people see the b up here and the b down here and they want to cancel, but you can't do that yet. Because you have to distribute first and then get a new b and then you could think about canceling b's. So let's distribute first. We're going to have the 2 on the 2, so it's going to be 2 squared. The 2 on the a to the 4th, which becomes a to the 8th. And then the 2 on the b, which will be b to the second power, over, let me just rewrite this bottom one, 32b to the 5th. Now, there's a couple of things we could do with this answer so far. I could change the 2 squared to what? 4. Scratch it out, just change it to a 4. And the 32 is 32. So I could look at the fraction 4 on top over 32 on the bottom. Could I reduce that fraction? What does it reduce to? 1/8. So on my answer, I have a 1 on top and an 8 on the bottom. And then let me focus in back up here and cancel out anything else that I could cancel out. Like the b squared and the b to the 5th, I could cancel out both b's up there with 2 of these 5, and I'll have 3 left on the bottom. So let me write that, 3 b's left on the bottom. And of course, we still have the a to the 8th up on top that we never moved. So that's our answer, but the 1 right here is unnecessary. They're going to not write it on the multiple choice answer. It's just going to be a to the 8th over 8b to the 3rd. That is your answer. Number 21. Again, I like to start by looking at the coefficients. There's a 48 up here and a 2 down here. So 48 divided by 2 is 24, and that would be left over up on top. So I want to do this. I want to scratch it out and put a 24 up here, because 48 divided by 2 is 24, and it is on top. Now, the m's, this guy, I'm going to have to move it down, and this n, I'm going to have to move it up. Okay, maybe I should do this with different colors. Let me do that. Erase. Different colors here. Okay, so I'm going to do this m to the negative 5. I'm going to bring it down in the front, right here in front of m. And since I'm doing this right now, I might as well rewrite it. I want to put m to the 5th down here. And I have the m that was originally down there. This m, I just wrote it right here in black. And then I'm going to take the n to the negative 3. And I'm going to put it up, and I'm going to put it up on the back side of the n to the 7th. So I have n to the 7th up here, and then I bring up the n to the negative 3, which becomes n to the positive 3. And we also have this p to the negative 4 that I'm also going to move up, and it'll be a p to the positive 4 when I do move it up. Are you with me? And let's not forget about this 24, because 48 divided by 2, that's 24. So we still have the 24 up there. Is there anything else that we could do with this fraction? Combine n to the 7th times n to the 3rd. What is that? N to the 10th. So n to the 10th power. I still have 24 out here. I have the p to the 4th over here. And on the bottom, I could also do what? M to the 6, because m to the 5th times m to the 1, add the exponents, m to the 6. Ladies and gentlemen, that is your answer for number 21. Fun stuff. 22, fácil. Answer is 1. Because the whole thing is to the 0 power, and anything to the 0 power is 1. Moving on. 23. I like to look at the coefficients first. 36 divided by 4. What is 36 divided by 4? 9. And that belongs on top, right? And then I'm going to go for moving negative exponents around. So before moving anything, let me start my new answer over here. I have a 9 up on top. Now this m to the negative 4, I'm going to put it out here in the front. So it's going to be m to the positive 4. But I still have this original m, so I'm going to put the original m right next to it. And then I need to take this n to the negative 2 and move it up there next to the original n to the 6th. So let me put the original n to the 6th up here, and let me move that n to the negative 2 up there, which becomes n to the positive 2. And of course, last but not least, we have this p to the negative 4, which goes up, and that becomes p to the positive 4. Wait a minute, was this identical to the previous one? Very similar. Okay, it feels like we just did this one. Anyway, what could we do? We could combine the n to the 6th with the n to the 2nd. We're going to multiply those, which means we add exponents. So our answer is going to be 9 n to the 8th, p to the 4th, over, combine the 4 and the 1, m to the 5th, and we are done. Moving on, number 24. What's the answer to that one? Are you sure it's negative?
Yes.
It's negative 8. It is. Now think about this. Negative is included in the parentheses. It's an odd number. So if you wanted to, you could expand it 3 times. But we know that a negative times a negative is a positive, and then a positive times a negative is going to take you back to a negative. The shortcut that we learned was that if you have a negative on the inside of the parentheses and it's odd, you know it's going to be negative. If you have a negative on the inside of the parentheses and the power is even, you know it's going to be positive, because you're going to be able to pair them all up. Anyhow, negative 2 times negative 2 times negative 2 is negative 8. That's an easy one. That is on tomorrow's test. How about 25? That's also on tomorrow's test. X to the 60, right? X to the 60. These are very familiar. I think these came out on last week's quiz, which is another good thing to study. We forgot 20?
26.
Oh, 26. Sorry. This one's tricky.
No.
Is the answer going to be positive or negative? Yes. If you have a negative in here, it's in parentheses. It's to an even power. It will be positive. So you know that it's going to be a positive answer. You don't have to worry about the negative sign anymore. But when you distribute it, you're going to have m to the 4th. Distribute it, p to the 4th. Now, is there anything to distribute on the outside of this parenthesis? No. So then that means that the parentheses are pointless. You could just erase the parentheses. I would erase them. I would just bring down the times m times q. And there is multiplication between all the terms. So I'm going to just rearrange it and say m to the 4th times m times p to the 4th times q. So m to the 4th times m to the 1, m to the 5th, p to the 4, q. It's always good to put them in alphabetical order. Of course, you'll see them in alphabetical order on the multiple choice test tomorrow. 27. Almost done with this. Again, we have an exponent on the outside. And what do we do with exponents on the outside of parentheses? Distribute into each and every one. So I'm going to take the 2, put it on the 4. It's going to be 4 squared. I'm going to take the 2, put it on the 5. It's going to be 5 squared. I'm going to take the 2 and put it on the y. That's going to be a y squared. The only other thing you could do is 4 squared is what? 16. 5 squared is what? 25. And of course we have the y squared right next to it. We are done with number 27. 28. Longest video ever. We have parentheses, but is there any exponent to distribute?
No.
Is there any exponent to distribute? So honestly, the parentheses are pointless. I'm just going to rewrite it without the parentheses. And of course, let's put some multiplication between each and every term. So instead of rearranging, I'm just going to go for it. When I multiply -2 times 4, what do I get? -8. When I multiply h times h to the 3rd, that's really h to the 1, that's h to the 4th. When I multiply k times k to the 5th, k to the 6th, and I am done. Number 29. 29 is 1. Why? Negative in parentheses, and it is an even-powered exponent, which makes it +1. That's right. And the last one is -1. It doesn't matter if you have an even-powered exponent. You really have to do the 1 to the 42nd power first, because that's not a -1 to the 42nd. You do a 1 to the 42nd power, that's +1. And then this negative sign, you just put it on in the front. So -1 is your answer for number 30.